Hi, this is Steve Dockery and welcome back to the Moot Workshop. Last week we fixed the record player from the Philco console, starting off with something mechanical, but this week we're going to have to deal with the electronics. We have two more parts to this thing. We have the radio, we have the television, and we have a power supply and audio output that support all those things. So we're going to try and make all that happen this time on the Moot Workshop. So the first thing we need to do is clean some of these things up. We've already determined that it doesn't work, and I actually looked at it and found out why it doesn't even start up, and that's because there's a blown fuse. Now, I could just swap in a new fuse, but the problem is something caused that fuse to blow. There's probably faulty components in here anyway, and some of them are bound to be faulty, like capacitors will definitely go bad over time. So we're going to try to replace as many components as possible, which is basically capacitors, capacitors, capacitors. Here we have the SAMS photofax for this unit. It includes a complete schematic. This is being really handy, but also a parts list and placements of all the parts. And so now we can see where all those capacitors go. Now, why is capacitors a deal? Well, the old capacitors, the electrolytics and the paper capacitors will degrade over time, and they just do that. Most of the other components degrade because of wear and tear, but capacitors degrade also just because they're old. So when you're restoring any old piece of equipment, the first thing you do is replace all the capacitors. So we're going to clean everything, and we're going to recap everything. Okay, now it's capacitor time, and there's a lot of them. This is just the first batch. We are going to replace a lot of these, so I'm not going to go through each and every one of these. We'll just maybe show me getting started and a couple of the highlights along the way. This is a Philco 10 microfarad 25 volt capacitor, and this is a modern replacement for it. It's a Sprague 10 microfarad 25 volt capacitor. So that's the difference between 1951 technology and 2020 technology. So I'm going to unsolder that part and replace it with this part. And we're not talking about delicate electronics like soldering onto little printed circuit boards. Making this stuff work requires a much more heavy-duty soldering gun. All right, so now I've got it out of there. So here's the code on the thing. There's 4 capacitors in here, 10, 50, 30, and 30, and they're marked based on these shapes: a half moon, a square, a triangle, and plane. And there's tiny little cutouts next to each of the connectors. There's the half moon, there's the triangle, there's the square, and that's the plane one. I marked these A, B, C, and D starting from the top, so now I know where everything hooks up. Because of the size of them, there's no good way to put these underneath the chassis, which is what I was originally thinking I might do. So I'm just going to stack these up and insulate the wires and run the wires down into the chassis and just basically replace it in the same spot as this. It'll just be a little fatter and funnier looking. So this is the ground up at the top and the connections for the 4 different capacitors on the bottom. Well, that's quite a monster. You know, although this will work perfectly, this is just really unsightly and I'm just not digging it. So as much of a task as it's going to be, I'm going to try to relocate some of those under the chassis and stuff the other ones into the can from the old capacitor. Now we got to figure out where we're going to put these under the cabinet. The problem is there's not a whole lot of space in there. This one is taking up a lot of room, and interestingly, I replaced this one with that. It was mounted in the same spot, but that isn't where it's shown in these pictures. There's a can capacitor, basically a cardboard tube capacitor, right next to this other one. And you can see that there's a socket, or what looks like one right there. So that capacitor would have sat like that. So what I could do is move that to the top vertically where the other one was, and then there'd be some room to put some other capacitors down here. There we go. 2 cans on top. And all the new wiring is the bright yellow stuff. Here's the 3 capacitors. And there we have it. Every single electrolytic and paper capacitor have been replaced. All the capacitors I replaced. Minus 2 of the cans that I repurposed. This one's the one that I didn't do anything to. I'm not saying all of them are bad, but I'm sure that quite a few of them are bad, and so I might as well replace them while I'm at it. This one in particular, that's nasty. These look like Tootsie Rolls. Those color bands on there are the code to tell you what they are. So that's 4, 7, and 3 zeros, and then you back it up 6 decimal places. So 47000 is 0.047 microfarads. Here's a modern capacitor, and you see that's 473. So that's 47000. So that's 0.047 microfarads. So having taken care of all of that, we're almost ready to plug all this in and make sure it works. We got 3 things, though, we have to consider. Thing 1, the least problematic one, is we have a broken plug come from the speaker, so I need to fix that plug. Thing 2, we need to close up the high voltage section over here. And one of the things that I'm kind of worried about, because we're talking thousands of volts here, is this cable that goes to the side of the picture tube. The insulation's a bit problematic on that, so I'm going to have to make sure that doesn't short on anything. Let me just caution you, there's voltages in the chassis of a television that can seriously injure, if not kill you, if you're not careful. So don't be doing any of this if you have no idea what you're doing. And one of the things is to make sure you stay off of all of the high voltage over here. So we're going to do all the precautions that we can make. And the last thing is, when I was looking over here, there's a note on the back of this saying not to try to operate it without the deflection yoke, which is the coils that go around to the neck of the picture tube, without those connected, because supposedly it'll damage some of the components. So we need to make sure we hook that up, and that's still hanging on the picture tube. So let's go take a look at that. So here's the yoke, and it looks burnt or something.
Something bad happened here.
I'm gonna have to take this thing out of here and see what kind of condition it's in. So as you can see, the yoke looks like it's gotten too hot and melted or something. I can't imagine what could have happened to this thing. Now, as bad as this looks, I did put a meter on it, and the resistances look okay, so it hasn't shorted or anything. So it's probably good enough for us to plug in and use for our test. So now we need to look at this wire. It's missing the rubber cup that's supposed to protect this when it's on the picture tube. So I'll deal with that later, but mostly I'm concerned about this insulation. The inner insulation still seems to have flexibility, so I'm not that worried about it, but there's this outside piece that's cracking. So I'm going to have to do something about this. That's substantially less scary. Now, because I don't have a tube checker, just to be safe, I've swapped in known good high voltage rectifiers in here. That's the 1B3GT and the 1X2. And then out here, I'm going to swap in known good 5U4Gs. Just, again, because there's no way for me to check the tubes that are in there. And because I like the shape of these better, which is a dumb reason, but I don't care. Now let's address that speaker plug. So there's the jack. See, it has 5 holes, 1 in the middle, 4 on the outside, and on the outside 2 of them are further apart than the other 2. Now here's the schematic, and you can see it shows only 2 wires hooked up, and they're the 2 that are the closest together on the one side. And so it really doesn't matter which way they go, they should both work. But here's the weird part. Only 2 of those wires are being used, but there's the jack you're plugging it into, and that has 4 of the wires being used. And I looked under the chassis, and all 5 of them are hooked up to something. We'll just go ahead and connect it to the two terminals that are closer together and fire this thing up and see what happens. Okay, so we're ready to try this. I've put the high voltage wire in a plastic jar. I've hooked up a makeshift loop antenna for the radio. We got the yoke coil plugged in and the record player, speaker, and all the things connected. It's time to try it. So here we go. All right, let's turn it on. I think we got it in radio position right now. Okay. Ooh, we got some sound. Oh, excellent. All right. We've got sound and we've got radio. Let's see if the record player works. All right, that should be the record player. Excellent. Let's try a record. Yay. Oh, wow. All right, well, it does distort if it's turned up too loud. One thing that could be causing this is a weak output tube, so I'm going to swap in this Philco tube, which is supposedly testing good, and see if that makes any difference. Another thing I'm going to do is clean the contacts in the switch here and in the volume control. So I'm going to use this electrical contact cleaner, which is basically alcohol in a can, to clean the switches here. Okay, we've swapped in that tube. I've cleaned the switch, and off camera I cleaned the volume control over here. So let's see if this has made any difference. Still on the radio, I should be. maybe. Yeah, there's a radio.
Appeal. You would definitely be tempted by the windows, and you think, oh,
We're still distorting. Got one more trick up my sleeve. Through the magic of shooting the video a little while later, I now have a new old stock replacement for that tube, which means that this is a tube that, although it's old, has never been used. So let's try and see if that makes any difference, because even if that used tube is, quote, good, it could be weak. So there it is, nice and shiny, never been used. Let's take this tube out. Put this one in its place. And cross our fingers.
Consumerism, which is really what it boils down to.
See, that's so interesting, because, you know, that might...
Yeah, I don't know if that's any better.
The male consumer would be...
Okay, so where does that leave us? The next thing I could try is maybe swapping out the speaker. I don't have an exact replacement for it. It's 3.2 ohms. I don't have one like that. I could probably come up with something, but it would take a little time. And also, if it isn't that, it could be some other component in the output stage, but I'm bumping up against my own limits of knowledge of electronics in general and this circuit in particular, so I could probably get on some online forums and ask some questions. That would also take a while. We don't want to draw this out forever, I don't think. I could fix those things later, but let's call this good enough for now. Which means what we have next to do is even see if the picture even appears on the TV. I'm guessing it's probably not going to actually work, but the only way to test that is to hook it all back up with the picture tube, which I can't do here on the bench. So what we're going to do in the next segment is we're going to clean up and put the cabinet back together, put all these things inside, try out the television, and see what we end up with next time on the Moot Workshop. Say, if you appreciate what you just saw, go ahead and like this video or subscribe to our channel, and we'll keep bringing you more quality programming.